So today we will learn about what is vector and what is scalar. So first thing first, why do you need vector or scalar, or more specifically vector analysis? So basically we need just because to represent a mathematical data in a more compact and neat way. So the historically it was developed by Willard Gibbs during the period of 1880 and 82. So much of the calculations in these various fields like physics, particularly in mechanics, electricity and magnetism, is greatly simplified if the result of the vector algebra and the vector calculus are employed. So that's how it all begins. So we will start with the definitions and the example of scalar. So by definition, scalar has only the value. If you get to know about scalar, so scalar is a lot of example will be there, like there will be mass, volume, energy, temperature, and so on. So everything is mass. You just need to say about it's like how much matter is contained in object, which can be 4 kg, 5 kg or something. If it's volume, it will be 5 meter cube or 5 liter. If it's energy, it will be 10 joule or 10 arc. For temperature, it will be like 10 degrees Celsius or 100 degrees Celsius and so on. So in scalar, you really don't require to mention the directions of the physical quantities. Now in the case of vector is really different, because vector requires two things. One is the magnitude and where the directions. Lot of examples like force. So if you tell that what is force, so you have to mention that if a box has been pushed by a man, so you have to tell that in which directions he is pushing the box. So the direction is necessary. So you can tell that this man is pushing this box in the east directions and with 5 Newton force. So that's how force can be represented. Now we will talk about types of vector. So what is the types of vector? So there is a lot of type of vector we need to know before we jump into the core of the vector analysis. So first thing, we need to know the main vector component, which is unit vector. So what is unit vector? So unit vector is a vector which has a unit value but has also a directions. Suppose you are moving to you are going to your schools, right? So here is your beautiful hand. So you are moving and this is your school. Fine, it's beautiful designed. So here is your school. So you are moving just right there. So when you are mentioning the distance from your school to your current positions, so what happens, you have to measure the value, like if it's 10 kilometer or something like that. So if it's 10 kilometer, you have to tell that in which direction. So you are moving to the east, considering this is north, this is east, and so on. So if you are moving towards east, then obviously you will be moving 10 kilometer in east directions, right? Now you have to mention that why this is 10 and what is 10 kilometer. So when you are measuring something, you have two parts. One is its magnitude and one its unit, right? So this kilometer is nothing but the unit. So in the vector, in the same way, you will be getting the unit vector. So if we just take a kilometer in this kind of scales, so I'm not to map, so it could be more and less, but it represents that every gap between them is 10, it's 1 kilometer. So 1 kilometer into 10, which gives you it's 10 kilometer, right? So that's how it all begins. Next point is null vector. So what is null vector? So null vector, the vector itself has a directions, right? But it don't have any type of magnitude or any type of amplitude. So here is the twist. So if any vector has a magnitude of 0, so it is called null vector, also called zero vector, and its amplitude is always 0. Here it's an vector, right? So we will always represent a vector with a arrow. It's must. And when we represent it, we will always take the alphabetical name and then we will give a head arrow like this. So and this one is called its magnitude. So this a vector has a directions, right? So if we take this a vector and we just move this into these positions, so it will be like this. So we can do that. So we can tell these vectors are equal by magnitude and also in direction. So basically they are equal. So if now another thing, if we move here but we rotate the vector like this, so this is b vector and we take the a vector like this one and we just move here, so here this a vector not equals to b vector, right? What is a negative vector? It's simply any vector which is represented by a, we can take the minus of minus a, right? And also it can be represented by minus b vector. So any a vector like this one, so this is a vector and phonetically we can represent the a minus vector, so minus a vector in these directions. So this is the minus a. So here you can see the difference is not the magnitude. That means basically the magnitude of a vector equals to minus of a vector. So basically they are same. So what is not same is its direction. So magnitude or scalar part of this vector is same, but very important is that a vector and minus a vector are totally opposite in directions. So here is another example. So if you take a vector like this one, so this is a vector we can represent, and also there is no limitations that we have to take this vector in this direction, so we can take it as minus v vector. So if we take this as a vector, so then it will be minus a vector, and if we take this minus v vector, so the direction is reversed here, so we can represent it by v vector. So that's all the basic part and introduction part to the vector analysis. So I will continue this vector analysis series in more depth in the next videos of this series. So if you are a college undergraduate student of physics or mathematics major or honors, so this course is for you, just because I will go very much deep.